Okay. I've had a few thoughts about what we're dealing with right now. Oh, that's good. That's really good. Yeah, I really, really, really did so well. If you're joining us, I'm trying to make basically a game with sailing, except I want to try to get the mechanics, um, like direct. So here's that, and we're having a bit of a problem. Is that it pops around like this, and actually here, I don't want to display this. So if I go down, huh? Well, for starters, it's like it's going the opposite direction again, which I feel like I changed the inputs. The inputs I got wrong because it's negative, positive, negative, positive, left, right, down, up. Huh. That's deeply frustrating. How is it negative and positive? If I go to the right, it goes to the right. If I go to the left, it pops over to the left. If I go up, it goes down. If I go down, it goes up. Um, all right. So, you know what? I was wrong. Actually, here. Forget that. Let's just keep it as is. Let's just go to the right here. Okay. I'm going to clear this out. And left. It doesn't seem to it's like it's printing everything, again, at a steady rate. It seems to be changing at a steady rate until it gets near to the end and then it drops off. The problem I have with that, of course, is that it's not visually doing that. And I have no idea why. But I came up with we're going to go back to this equation for a second here. I want to just see what happens when you directly feed into it. Okay, so for starters, the direction is completely opposite. And that might honestly tell us more about this than I don't know. What if I just flip the vector? It's weird. Okay, now it's just really... If I just do this, it looks like I've got really wide sails. Yeah, which is awful. It's also still going in the opposite direction. And I mean, I'm not surprised. Yeah, what the heck? Okay, if I flip all of these, is it going to be like correct? This just feels awful in every way to do. It feels confusing. It feels like I'm throwing my intuition out the window just to try to make things work. Oh. All right. I don't know. Maybe if we just flip everything around. Okay, if we flip everything around, it's actually reading the input properly, which is good. And of course, like I said, I want it to slowly move around. All right. So let's see. From here, instead of setting it like this, let's see here. We have our target. So instead, I'm gonna make a tween here. Tween is the weirdest video game term. Actually, here. Let's call this sail tween. I should call it mast technically, because that's what. No, we're not really moving the mast. Yeah, we'll keep it as is. All right, so we're gonna make the sail tween. And instead of saying current vector, we're also going to have, let's see, target sail vector. And we'll make it up as well. We'll make it up. I want both these to start out down, actually. So these will start out down, and all right, so let's see here. Oh, no. Sorry. We have to create, and then we're going to tween a property of the sail route, and we're tweening. Oh man, what are we doing? We're rotating. No, I shouldn't do tween property. It should be tween method, I think. Yeah. So sail route, and we're gonna rotate around Y. And we're going from our current vector to let's see here, target sail vector. No, wait. Let's think. If input's different from target, then the first thing we're going to do is set the target equal to the input vector. And from there, our target, forget everything you know about this. All right, from there, we're going to create a tween, and we're going to say our target is, no, I'm sorry. That was correct. From the current sail vector to our target sail vector. No, that's crap. We don't want the vector. We want the angle. We're using... Here. Let's just create some new ones. Angle. We got to throw Kurt Angle into the mix. All right, so 0, and you'll be 0. All right. What? Oh, right. All right, you'll go over here. All right, so there's our sail. And let me think here. I want the angle for this. So input vector angle, and that angle should just be yeah, from that x-axis. Okay. There we go. So we're going to get the input angle, and we're going to say if the input angle is not the same as the target angle, then we're going to set a new target angle. And then we're going to go whatever our current sail angle is, go to the target sail angle, and what should the duration be? The duration should be based on, let's see. I wanted to be able to rotate I think, let's say pi. Times what? Actually, it should be a product of the like the target angle. Because if the angle's long, I want the duration to be longer. If it's a small angle, I want it to get there quickly. I want this to be constant. And I know, I feel like I should just be able to rotate this constantly. But that's not working. It doesn't get to the right spot. Tell you what I will do. Maybe I'm just doing all those equations in the wrong spot. Why are you mad? Oh, because you're a vector. Flout. That's a new type in Godot. Don't ask. All right. So, let's see. Update the sail. Actually, we should only update the actual angle as long as we're doing inputs. Yeah? Okay. So sail route, rotate around the y-axis towards the target angle at delta, and sail rate of change, which is currently 1. All right. So let's see here. We update the target, and yeah, we don't even have like a current, and that's fine. Okay, let's give this a go. Okay. Wonderful. And by wonderful, I mean awful, because now it's just constantly rotating, and that's because we oh, I should probably all right. No. What am I messing up here? Oh, shoot. Of course. All right. If we're not equal to our target. All right. And then our current sail angle will just be sail root angle. Sorry. Sail root. Oh, yeah. I absolutely hate this. No, actually, you know what? Here. Yeah. Okay. So this will adjust. Eventually, I mean, they have to equal each other, right? Right. I'm hitting left right now. I'm hitting right. Oh my god. I hate dealing with this crap. It was working so much better beforehand. No, this is trash. This just feels like a trash approach. I don't like it in the slightest. I'm so overwhelmingly confused that, like, oh my god, stop. I'm perplexed at why doesn't this just work? Oh, come on. Help me, Tom Howard, please. Yeah. It's like we have an input vector and a current vector, and we're moving towards it supposedly at, you know, a fixed rate. I have a clever plan, my lord. All right, let's try this. All right, everything's backwards again. So wonderful. I think it's just up and down or backwards. This whole world is just topsy-turvy, man. All right. That's up. Should be down. I mean, who knows? Wait a minute. What's our camera angle like? Yeah, okay. Slowly. Slowly. It's like it picks up speed a little bit. Over here. If I go directly left, it moves so slowly. Like it feels like it moves. Maybe it is just going the same rate. Can someone time me? Yeah. If I go directly left, it doesn't move for a second. And I'm wondering, I'm like, is the vector that it's like aiming at really going through the center? This is why I wanted to use angles, but eventually you get into the problem where you're in 3 dimensions. And now everything's just topsy-turvy and garbage. I just want to rotate the y-axis. And I feel like I can't do that. I mean, you can, but then it won't work. Because then it's like, it doesn't know what's happening. This is distressing. I still don't understand why the heck none of this crap works. And why does it start out, I don't, like what? The sales should start out down. Okay, they do. I guess I had to change that value. But if I hit the opposite, look how long it takes. And then eventually it just starts picking up speed. And it's like, all right, but why? Why did it take so long? Again, I feel like this would be, all the angles, it feels like it would be perfect for. You know what? Here. Let's take a moment and just look at how things are changing. Let's go to the right. Okay, now I'll go directly to the left. Here. Wipe that. Huh. I still have this posted. Confusing to read these messages. All right, all the way to the left. Moves very fast whenever you're close by. All right, clear that out, and then to the right. And we're looking like You know, there's our difference. And then it starts to speed up towards the end. It's like we're in this real nice sweep spot here where it moves quickly. I don't know. I feel like move toward is not... It almost feels like the vector is not rotating around, but passing through. And normalizing it seems to have kind of helped. But it still feels like we're suffering some fundamental problem here. So I'm just... All right. We're going to go back to this. Our current sail. We're getting the angle. And we're saying... Here's the target. Here we set it directly equal to, but what I want to do... See, rotating this finger by an angle. Let's say segment. Segment's a terrible name, actually. Delta angle. All right. So we get the difference between the two. And then we say... I think I'm... Well, I kind of got it to work, but in a really weird way. That's trash. So let's do that for starters. What on earth? Okay. Hmm. Oh, shoot. Calculating it twice. Mm-hmm. Here. This is kind of messy. It's really messy. In fact, I feel like this rudder part should just be... Yeah. It's almost like the rudder thing works fine. It works more than fine. You know, you get the difference. We're going to upgrade it. So it's weird. I'm like cranking the input around. It's almost like something is... Wonder. Oh, gosh. All right. Let's just print one thing at a time. I'm going to change target to target angle. So I'm mindful of what I'm doing. All right. It seems like the change in angle is happening instantly. This is like, it's almost like this thing is, the vector is rotating very quickly. And yet, when you try to rotate the Y, it's moving slowly. And I am so perplexed because they both take radians. I'm like, why is one of these rotations calculating faster than the other? Still, all right, I'm going to do this again. All right, target sail angle. If it's different from the input, we have a new target. And then let's say if the target sail. Oh. Actually, input vector. No. Oh, nuts. Huh. Why won't you work for me? Front? Oh, God, I hate every part about this sometimes because it just feels like pulling my fingernails out. No. No, 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 no. Oh. It's definitely got to be the vector. And here, input vector, not recurrent. So, right. Wait a minute. Oh. Oh, I think I figured it out. Oh, I think I may have figured it out. I really, really hope I've figured it out. It kind of slows down still. It really slows down still. Still, I like it. It's not doing that weird, like, let's go all the way to the right, yeah. It's not doing that weird snap thing. It seems to at least move with, I don't know, some sense of purpose. What I wish is that it would move at the same rate. And I think I could get it to do that. If I'm, let's see here, var target sail. Ooh, vector. That's set equal to current. Okay, down here. So instead, we're going to say, what are we doing first? We're going to get the target cell angle, and then we're going to say the target cell vector equals the input vector. So this should only update once. But what will happen is that as long as we have some kind of input, let's see, this, all right, we're going to rotate, and then we have our fixed angle. We're going to get product of that. We're going to rotate our current vector. We're going to say if current cell vector is not equal to target cell vector. Okay, we'll get a change. We'll rotate it, and we'll rotate the root. You're mad, you want this. Okay, let's see if that gets us a little more constant behavior. Kind of. Yes. It's constant. But it's also evil. All right, I like how it was before. Let's just change it all back. Oh, that was awful. That was just terrible. Let's run this again. Yeah, it's kind of there. You know what? It works its way over quickly when it needs to, and it slows down when we're trying to get precise. And of course, we can just leave it there when we let go of the stick. All right. Well, that was painfully more time than I ever cared to spend on this. Oh. That was just aggravating. Does this need to be here? I don't think I need to store this, do I? No. Okay. Wow. Well, that's yeah, it's kind of slow. So instead, let's make it a little quicker. Because I think the rudder is fine. So all the way to the right, to the left. Okay. I'll still make that faster. I'll make the rudder faster too. There we go. And oof. All right. That was terrible. I hate that. I absolutely hated all of that. I hate it because it was so painful. But we do at least have one part, and I've been at this for a while now, so I'm gonna call it for here. Well, maybe not. I need to take a break regardless, so I'm gonna take a break. Thanks to Ark and Storm who stopped by. It was like y'all stopped by and I didn't acknowledge it or I wasn't here. So we're doing great. We're doing this streaming thing real well. All right. See you in a bit. Okay. I tried to set up audio alerts earlier, and it just seems like a complete mess. So I don't know. Maybe we won't. Maybe we won't do that. Okay. You know, I just realized something. I should. Let's see. That's the website. Let's open up our terminal here. Godot. What do we call this one? Sailing sim, right? Yep. All right. So we should have. We have a get ignore. I think you still have to. You have to still do get ignit. Yeah. Okay. Cool. At all. Let's just say init, and I'll just say what do I call it? User inputs. Added. Let's see. User controls. Yeah. Oh. Forgot to update the README file. Rudder control, sail control. Let's see. We're not doing this. We're not doing this. We pass rudder into boat. We're technically doing that, though it's not. Yeah, we'll just say this. Control rudder with the bumpers. Control stale. Whatever. Let's see. Get add readme.md. Get. Should it be add? You know, I like doing this in VS Code. And the reason why is because, yes, I trust myself. Do I trust myself? Doc updates. Yeah. And we'll push that to main. Boo, boo. Oh, no, we won't. We don't have we don't have anywhere to go. So let's go to GitHub. Let's create a new repository. I really encourage this to anybody who's doing anything with software. Even if it's just like a demo or something, put it in there because if you ever come back to that tech, it helps to look and see what you've done before. But also it helps to, let's see, I'll just call this Sailing Sim. Sailing Sim. Let's see, I don't want to add anything to it. And we'll grab that. And yes, it's okay. Push to main. And we should have at least our first bits here. I'm going to mess around with some of the security, so hold on a minute. Here, take a look at Microsoft Paint. Yeah, you remember that? Wonderful. I don't know. I need to add. I want this to be open, but I want to add some branch protections. So, let's see. For main, let's see. Let's add it. Wait. Restrict deletions. Block force push. Made to a non-target. Wait, all commits made to a non-target man submitted via pull request. Yes. Conversation resolution approval. I'm only going to allow squash. Let's see, status checks to pass. Cool. Okay. Oh, ho, ho, I need to enter my password. Yes, see? Hold on a minute. Okay. Which one is it? Who am I? This one, I believe. Cool. All right, no one should be allowed to push to main. In fact, we can do a real simple test of this. Oh, whoops. So, let's look at the README file here. And we'll just say test. Okay. Test branch protection. Cool. What, seriously? Okay, that test failed. Why? Look again. What the heck is this? Just take a look at this. Wait a minute. Branches. Add a rule set. I already have a rule set. Don't I? Yeah, main. Disabled. Why would you... What? What? Why? No, I made it. Why is it automatically disabled? Here's a rule set. Will it work? No. All right. Well, here's a good way to reverse it. Let's just erase what we just wrote. Retest. All right, push again. Huzzah! Good. You can't do that. All right, cool. Thanks. All right. Well, in that case, we'll just have a new branch. So get checkout B. I'm going to add my name to this. And what else do I need to do? I don't really need to add my name to it because I'm pretty sure it'll already have that. But what is the point of this branch? We should add wind. Yes. Excellent. And we should be able to... push this branch, which we have. So if we go through here, huzzah. All right. Okay. Let's see here. You go away, and you go away, and you go away, and you go away. All right. Discard local and reload. You betcha. All right. Next, we're going to add wind. We're going to work on this branch. I don't think I'm going to do the flag yet, because that's like down here. We'll save that for the last bit. Okay. So let's get something in here. Let's call it wind. And for that, we're... let's see here. Can I... You can do a visual raycast, can't you? Oh, there it is. It's hard to see. Oof. All right. Let's move up a little bit. Yeah. Oof. Okay. Stop doing that. Oh, right. It needs to save. No wonder his quit bothering me with save details. Come on. I don't have time for that. All right. Wind. And the wind is going to have two things here to export. We're going to have direction and a vector 2, and we're going to have magnitude as a float. And we'll just start off with 10. Okay. Now direction, I want it to be, this is kind of weird. I don't want X and Y. It's almost like I want this to be X and this to be Y. I guess I could. I wonder if I can give it like a custom vector too. I could. Just feels like really annoying for me to try because there's a lot already in here. I feel like that's going way beyond. The real question is, I think X we should set to X and Y should be negative Z. As weird as that is, I feel most comfortable with that. So let's think here. Function, we're going to have get wind. Hey, got wind. All right. And we're going to return a vector 3 instead. And we're just going to say, I want a vector 3. I want the direction. I want nothing in the y-axis. And I want 0. I realized I just passed a vector 2 into a float. And then the magnitude. So this should be our unit vector. Is that like a type? Vector 2. What is I? I don't think I've... Oh, okay, well. I thought it was imaginary. I was very mathematically excited for a moment. You know, I want to be able to, if you move this. Huh. Pointer. I know some of you are screaming out in C++. You're crying out in agony, some of you, but I don't care. You're going to suffer here. This place of suffering. No. Let's not do that. Can we? Let's see. You set value. And first thing we have to do, weirdly enough, is do this. And then I'm going to set the direction. But I'm going to do it as a unit vector. And I'm going to say, okay. Value dot. This isn't just a pointer. Say it's a raycast 3D. How do you get the direction from a raycast 3D? Do you get the direction? Maybe this is a bad idea. Huh. No, it'll work. Um, hmm. Shoot. I'm really trying to think about this. I don't think I want to do this. I think this is a lot of effort, and I don't see the immediate payoff. We're not going to have anything displaying the wind. Instead, we're just going to set it to a value which should exist. In fact, I feel like the direction is a little confusing, so I kind of would just say direction X and direction Z, just so there's no confusion over like which is which. Let me think here. Can I? Yeah, range. Okay. 0 to 1. All right. So we're gonna cap it because I just want it to be like a unit vector, and the magnitude will be the actual speed. All right. So direction X. No, that's not an X. I've been betrayed by my own hands. Direction Z. Cool. So we're gonna get wind. Let's see here. What are you? Oh, shh. Don't look at that. That was a mistake. All right. So for our level, we're gonna have wind. Should wind be separate? If wind is separate, I'm like, what is the level for? Huh. No. I think I'm going to add it to level. There we go. All right. So we've got wind, and we're going to go full in the Z direction. I wonder if I should make that. Oh, you know what? Oh, shoot. I just realized something very important. We can't go from 0 to 1. We got to go from -1 to 1. Yeah? Because if we don't, then we'll only be able to travel in like one quadrant. So, the wind... God, that camera. It's horrid. I'll move it back a little bit. Angle it up a little bit. That's like way too far back. And not enough angled up. It's an art, this, you know? Wait. Yeah. Okay. There's that. We've got our wind. Yes. And here in our level. Let's say the direction is -1. So it's pointed that way. Magnitude of 10. Which is all fine and dandy. But of course, that doesn't really do anything for us because that's just the wind. Yeah. We can add that in here anyway. We can just say added wind. What changed here? We moved something. Something with the boat. I don't really care. Here we go. We'll make that its own little commit. We're not generating wind yet, so I'm not going to mark this off because it's manual. But we can do this, which is, of course, when the wind becomes useful to us. So let's go back into our boat. And what do you think here? We can pass the wind into the boat every time it rains. Oh, actually, you know what? We should probably pass the delta. Okay. Here we go. Wind. We've got boat. I like to tell it the custom class. That way we can actually see any kind of functions or properties in the editor. And then every update, we're going to say get the wind and just pass it into the boat. See, already this function's gotten like large. It's clunky. I don't like it. Let's see. Accept wind. Calculate wind projection. And here's the wind. It's a vector 3. It is a void. I'll just do that for now. Boat, calculate wind projection, and wind, get wind. Cool. So that's happening. And I wonder, I won't pass delta for wind. Or should I? I think I should only use delta when I'm actually doing kinematic stuff. For now, I'm just not going to do it. Wind projection. It's going to be, maybe I'll keep it a vector 3. All right. And our wind projection is going to be, let's see, we're going to have the wind and dot with another vector. No, I don't want the dot product. Oh, yes, I do. Or do I? Oh, how do you solve a problem like Maria? All right, let me think here. What are all the little equations we could use? Direction to, distance, dot, floor. Is there no projection? Project. New vector. Resulting in this vector onto a given vector B. The resulting new vector is parallel to B. Okay, so here we go. Project, and what are we projecting? We're projecting the sail route, but not its location, its direction. And we should be, let me think here. Should be global. Yes, global basis. And which one is it? All right, so This is, oh, whoops. This is the boat. And we want the X direction. And ultimately, we want like the absolute. Because I don't want, okay, let's say the wind's blowing the sails this way. If the wind is blowing this way, I mean, it'll pick up on that X direction. But if we rotate this way, we don't want it to be like negative, right? Because that's like projected onto this vector would be, well, actually, it would probably just give me the negative vector anyway. All right, so let's keep it as is. Whoops. And I don't want to do local. Yeah. All right, so global X, and that is going to give us our projection. And then let's see. I should do this in like a different little area here. Input processing. You I want to speak to. All right, there we go. Cool. It just clears out that main function. So input processing, and what are we going to do this? Now we're actually going to do the kinematics. So boat. Oh, phi. This has to change types, but that's okay. What type are we going to use? So we need something that moves. Oh, collision. Let's see. We don't want to do a static. We don't want to do, I suppose, rigid body. I don't want to do a car. This is like for moving platforms. This is, yeah, can't be moved externally. Which I guess technically it's not. We'll do the rigid body because we don't have I don't know, maybe I should do character body. As it says moves by script, so let's do that. Character body, you need a mesh, don't you? Yeah. Do we? Hold on a minute. No, wait a minute. I don't need to do this. I can do my own math. We're fine. All right. Let's see here. Let's make a little region here. Inputs. Whoa. Cool. Goodbye. Whoa. Oh, God. I hate when it does this. This is... There. Okay. Make another region. Cool. You know, someone once gave me really great advice. They're like, there's no reason to put a comment if like your functions and variables are obvious enough. I mean, they're right, you know, like I just typed the word kinematics and it's like, really, what am I doing? Just what I said. So, all right. Let me go here. I want the boat. Oh, right. No. I want to translate a particular direction forward, but that forward needs to be based on the wind projection, which is global. Let me think. We have a global value and a global value. And I want this based on local. So I think I have to say this should make it based on the boat. Now, oh, you know what? Wind projection. Now we're going to project that onto, let's see. Does this node position, translation offset? In local space. I think this is global. So we don't want it to be local. Project. But only in the X direction, so global basis. No, not X. Z. That's kind of messy. And this might not work at all. Let's see. I can't tell if I'm moving. I am definitely moving. Wow. Hold on. I'm sure I'll get copyright for this, but I just have to make this joke. Skip ahead. All right, get ready. Let's crank it up a little bit. I wish I could see behind me. I'm probably long gone. Okay. Wow. Oh, man. Let's turn that wind down, huh? That is way too much. I know what I need to do. I know exactly what I need to do. We probably should factor in delta. Okay. Yeah. All right. So we're moving at good speed. It's not too fast. And we are No, are we? No, we're just translating. It should be. Yeah. All right. Let's see here. That's good. That's fantastic. We just got wind working. Huzzah. All right. But there's something else I forgot. We need to, okay, I'm going to say move forward. And you know what else, actually? I want to do, hold on a minute. So that moves us forward. So does this. Good. This doesn't move at all. Yeah, we're still moving forward. If the wind is like +1, we start moving backwards. Yeah, I mean, okay. We'll say it's fine for now, but we should be aware of it. Rotate boat. All right. We want to be able to turn. We really need to be able to turn. So, our rudder is at an angle. And we should rotate according to that angle, but it feels like it needs to be Let's say user controls. I'm going to call this control surfaces. I don't know if that's the sailing term, but that's the aerospace term, and that's what I'm going to call it. And then this is going to be kinematics. Okay. Whoop. Rudder, I'm going to call this effectiveness. Because I think there should be some kind of decay. And I don't even know what that is, really. We'll say that. I wonder if sail effectiveness would also be a thing. I think so. I don't know. I mean, I feel like there's got to be, like, sails that are very advanced. I don't know what those are, what they would look like. But I'd like to think they exist. I'd like to think that's a real life thing, and I'm just going to believe that it is. So let's do that, and we'll multiply that by our sail effectiveness. Rotation. So we're going to rotate around the y-axis. But what are we rotating? Current rudder angle. Current rudder angle times delta times rudder effectiveness. All right, let's try that. So move forward a little bit. And we are rotating, but there's a bit of a problem. Can you tell what it is? I've created a new type of sailing. No need to thank me. We need to go the other way. So there we are. Now we're rotating. Good. Look at that. It's hard to see because we just have like a flat nothingness. Let's think here. How can I put it in the level? Yeah. All right. I'm just gonna put a bunch of like. We should make a new asset. And we're just gonna call it buoy. Is that how you spell it? Buoy. But is it Bowie or buoy? It's buoy. Whoops. All right. Boy. And there we go. The English language is bastard language. I don't care for it and I won't respect it. This is a real punk channel here. Cool. All right. Oh, you know what, actually? Here, we'll add a few. Yeah. The pillar is... Whoops, not that. I want the cylinder. Yeah, we'll make that... Make it kind of wide here. But, more importantly, we're going to add another mesh. And I'm just going to call this the base, because I don't know what else to call it. All right. And, what is it? This one? Whoa. How do I make the whole thing bigger? Probably this. Whoa. All right. Oof. Okay. Yeah, radius 1. Make it a little smaller. And I feel like this should sit a bit lower in the water. Yep. And I want to color it because I don't want it just to be gray. So we're just going to give it a kind of vibrant red. Or a reddy orange kind of color. So yeah, we really want it to stick out. So we'll do that. We'll save it. And the pillar is actually what we should do is whoa. We should save the material. Boy material. And for the pillar, we're going to use the same one. Cool. Oops. All right, neato. Now on our level, we're going to bring our boy here. And I don't know. Let's just like put a couple around. Whoa, what the heck? Okay. Eager little fellow. You know what? No, this feels sloppy. We should make a little race course. Oh, that'd be fun. Let's see here. That's fine. Okay, so here we go. Here's for that. And you're gonna go here. They feel way too close. Oh, I can't click it because it's... Can I? Why not? Boy, now I'm making a racing game. It all happens so fast. All right. Yeah. Okay. And we're going to do this. And say you go over here. And then we'll duplicate you again. And rotate. And... Ooh. Weird. Oh. Here you are. Cool. Neato. Ooh, whoa. You two. copy you, put you over here, rotate you around 90 degrees. Can I look at, yeah, okay. There we go. That's nicer. And then we're just, oh, no. Oops. Oh, gosh. I don't know why I can't grab any of these. Oh, no. Yeah, sure. Duplicate. I feel like I'm not pronouncing that word right, but maybe I'm just being self-conscious. Duplicate again. Oh. Golly. What? Oh. Whoa, no, not that. Duplicate. Cool. Yeah, all right. Rotate 90 degrees. All right, and stop. Oh my goodness gracious. Okay. Here we go. There's that, and okay. Whoop, we're good. All right, let's see how this plays. Okay, so we're going to have a little wind in our sails, and this is our throttle, yeah? Obviously, if we're like this, still we're only going to get a little. Now let's do a little turning. Oh, something is happening. Oh, something very strange is happening. Oh, no. Stay calm, everybody. It's fine. I'm sure. Okay, we're we're moving forward now. Yeah, this is good. This is a good boat. This is a good boat. See, this is why you need to make little test levels, because you're like, oh, surely this will work, right? I don't need to double check my work. I'm sure it's fine. Listen, we've got standards here. This isn't EA, for heaven's sakes. This isn't a triple G. It can be anything you want here, but like this is not a triple A gaming studio. This is a triple gay gaming studio, and we put in the work. We get it done right the first time, all right? That's our motto. Yeah, this is rough. This is very rough. Many things are going wrong. Okay. Well, I think I know where to start. I mean, I don't know where else to go. It's literally just this. I think I know what the problem is. Is it those 2 lines of code we just added? Okay. Huh. All right. I only want to move forward in one direction. Maybe I should do this in local space. Yeah. Mm. All right, so first let's say translate object local. Hmm. All right, wind projection is, let's see, it's still global, yeah? What if we made this local? What if we did this relative to our local space? And then we said, let's see, project on a global basis. In fact, if it's just the Z basis, it should just be the Z direction. And I'm wondering if project is just too much. Like, is it cheaper just to turn it into a vector? Here, we'll do this for now. And we're going to say the negative Z. It was before, wasn't it? No, we got to think of it. And if it's projected in this direction, it should only be, like we should only have one value. In fact, we'll print it here. We'll just say boat, call this the velocity. All right, here we go. And the wind. The wind. Yeah. So I want to make sure these are different values. So there's the wind projection. And then just the wind. Oh. Wind projection. All right. Cool. So we've tried to do things locally. All right. Good. It works as it should. Now, the real test. Turning. And I feel like I'm still seeing this, like, tell you what, let's turn like this. Okay, we're getting like a weird behavior. All right. We should not be moving because the wind, remember, the wind is pointed this way. Our sail's perpendicular to the wind. So if I do this, I should move forward. But I'm not moving forward. I'm moving sideways. And I want to know why. Huh. And yep, and now I'm moving backwards. Which is very weird. Wait a minute. Go, get me back over there. Yeah, my velocity should not be dependent upon what direction I'm facing. So I think projecting... I feel like projecting the basis, yeah, we shouldn't not do that. Okay. So instead, I'm going to say vector 3, vector 3, none in the 0, none in the y, none in the x, none in the y, and then negative wind projection. Huh. What am I doing wrong here? I know what I'm doing wrong. This should just be a z value. What if I should make it negative? This is just in the z. U. Oh, right. Okay. So, maybe I don't need to go negative. We'll keep it for now. All right, so we're going to try to move you in the z direction. Let's see. Backwards. Yep, all right. Should have known. All right, here we go. Okay, good. We're moving forward. And if we turn just a little bit, yeah, we should still move forward. Okay, so if we, whoa. I feel like we should not be able to move. Oh, what is going on? Oh! Yes. I know what's wrong. Can you spot the difference? I hope so. We're toast, chat. We're really toast. Yeah, this is weird. Oh. Jeez. Oh. Oh. Well, whatever. Actually, we want this. We want this to be there because we want to look at it in the future. And by the future, I mean a few moments from now. So, in fact, maybe we could let's just run the debugger here and show you. All right. We're pointing in the right direction, but more importantly, remember the projection on the ship. Why is it still printing this message? What? Oh. Shh. I didn't make mistakes. All right. Notice our wind, yeah? Here we go. It's our projections in this negative direction. Watch what happens when we turn. Right? We're going to turn sideways. Notice how we get faster. We're picking up more of the wind, right? But worse than that, when we turn around, it's negative. And weirder than that, it's negative like when we're facing against the wind. And if you remember from the very beginning, that's not really how it works. Like, we should be... Excuse me. I do need a vector. I do need a vector. Because I need... Oh, this is going to be weird. We should be able to point towards the wind and still go forward. We don't ever want to move backwards. Oh, what am I thinking? Hmm. I'm trying to dig my teeth into this one, really. We have to have a dead zone. We have to have an area that we're not going to make any progress on. And everything needs to be lerped. This is going to take a while. Oh, man. My brain is stalled out. So this is boat equations. At some point... So we get the projection. We asked for the z-axis before. Huh. This feels like the wrong approach, though. Because we should not start moving backwards when we go a little past 90 degrees, yeah? And if we just get the z-axis, if we project it onto, like, relative to the boat, that's what we're going to get. I kind of wonder. Oh, it feels like we're going to have to do a few different projections. We'll have our wind. Gee whiz. Okay. Let's see here. We have something else we calculate. Wind, like effectiveness. Because, as the wind is blowing upon us, so as the wind blows, it's going to be most effective when we're pointed away, when it's the wind's at our backs. And as we get to here, it's very little effective. And of course here it should be non-effective at all. So Wind effectiveness should be some value like lerped from here to here. Let's think. What does it do? A dot product? Maybe. No. We don't want it to be negative. Not a dot product. So what? Wind effectiveness. Some kind of angle. All right. Oh. No, actually. Well, let's think here. It'll be based on the angle between the wind and the boat. So, you know, we could probably just say, let's see, the boat's Z direction. Angle 2. I wonder, vector 3, unsigned minimum angle. Yeah. I think there was signed angle 2 as well. Yeah, I don't care about that though. Angle 2, the wind itself. Actually, I'm going to say what's the wind's angle to us? Basis Z. And then we're going to say, wait, no. Not angle. Oh, nuts. Yes, wait, no, yes, it should be angle divided by pi. Right, so it's going to be based on pi. Let me think here. Angle 2. No, not pi. Because we want it to be maximum when they're aligned. And if it's the angle 2, it'd be 0. So 0 is when they're aligned. And we want to make sure that angle is oh, what is it? We want to make sure it is maxed at 0, and at 1 we want to make sure it just sucks. Or not 1, some other value. So let me think here. I should tell you what. First, let's calculate a weight here. We're going to clamp. We're going to clamp this angle. So I'm going to say we've got an angle here, and I want to clamp it between, I don't want pi. I don't want pi. Max rudder angle, const, wind effective angle. I'll say this is the wind loss angle. So anything past, gee, I don't know. It looks about, you know, this is about a 90-degree slice. So I'd say, gosh. All right, it's 135. No. Come on, we can do this in pi. Pi 3/4. Yes. All right, pi 3/4. Anything past that? Whoops. Let's see, wind loss angle. Cool. All right, so we're clamped to this. And that's to make sure we don't like go into any like weird negative values. So our weight, actually no, it'll be this divided by pi. No, divided by the wind loss angle again. There we go. And now the weight is what actually we're going to lerp because we just want this to go from 0 to 1. What, do that? You know what? That and absolute. You're so angry. We got the absolute value of this angle. Actually, we're already going to get it because angle 2 is unsigned. So we get some angle between 0 and pi. But we want to clamp it between 0 and the wind. We want to clamp it for the wind loss angle. And wind loss angle is when it's going to be maxed. But we don't want to max it out. So let's see. Wind loss angle minus. Yes. It's all coming together. Oh, that seems so much. No, that feels weird. Here. Actually, no. Yeah. Here. Clamped angle. Am I spelling clamped correctly? Sure. All right. Clamped angle is I just want to move some of this to a different line. It's a little clearer what we're looking at. Okay, so why this? We do it this way because we want to make sure that when this angle is 0, that's when it should be like, that's when the effectiveness should be like at its max, yeah? And so this minus 0 over this is 1. Yes, okay. Oh, actually, that's already going to be it. Because it'll clamp here. Yeah, we don't need to lerp anything. Yeah, so this will actually be the wind effectiveness. It'll go anywhere from 0 to 1. And if we face the wind, the boat's just like, you know, like we're just not going to get progress. Because that's what they said on the internet, okay? And I think this will be good because it is, again, it does. Oh, it clamps it, but does it lerp? Kind of. Yeah. I think that'll be good. Okay, now we have wind effectiveness. And that wind effectiveness, we should feed it actually directly into the projection. So, why are you spaced out so far apart? Whoop. There we go. Yeah. So we have. What is going to be the wind projection? This is kind of weird because actually tell you what. Let's not do any of this. We're going to project it off of our sail like we said we would. And then we're just going to calculate the wind effectiveness directly. Yeah? Will that work? That's a vector. I should be throwing an error here, actually. Let me think here. Wind project. No. No, it's not just the effectiveness. It should be the magnitude. Oh, nuts. Length. There we go. Cool. So this will give us just the absolute value of the wind. So this tells us the angle, right? So we get the effectiveness, but then in order to get the projection, we're going to say like how effective is it? And that'll be a product directly related to the angle that the boat is according to the wind. And then we just take the magnitude and multiply it by that angle. Okay, so now we have wind projection, and that will be, should be our local Z. Okay, let's try this again. I'm getting problems. Getting some immediate problems. Can anyone tell me why? Because we didn't factor in the sail. Okay. Yeah, tell you what, let's bring all that back. All right, so we're projecting. We want the length of the projection of the wind. Oof. Yeah, because we've got the, x-axis of this. I wonder, let's just see. All right, it's working in the backwards direction. Let's try this again. Still working backwards. What the heck? Hmm. Hmm. I have a feeling this is still going to throw us off. Eh. Hmm. I literally just renamed it projection. Direct projection. Yeah. All right. Effectiveness. That. And projection is going to be that. Actually, call this one direct. Not direction. All right. And wind. Whoop, whoop, whoop. I can hardly see my own keyboard. Wind effectiveness. Direct projection and wind projection. Okay. Let's just see what the heck is going on. All right. This is mad. Fine. Take a vector. That's... Hey, the letter 5. That's not a letter. That's a number. I'm doing it wrong still. Why? What? Oh. Why are you still so angry at me? What do you mean? I just saved this. Oh, gosh. Can you not? Okay. Yay. It's always positive, which is good. Deja vu, huh? Yeah, we won it, and now it's probably in the dead zone. Yep, and it's back. Still moving backwards. Okay. All right. We're at full effectiveness. Now, as we turn, our effectiveness should start to drop. And we can't go forward at all. Even though the direction is like, look, I feel the wind. But our boat's not going. And now it's starting to, barely. Right? So let's sail a little bit against the wind. I made a terrible course. I just realized because we can't move. in that direction, can we? And we shouldn't be able to move here. And we can move here. You know, I mean, we should be. Is this how the ship looks online? Kind of. No, not at all. All right. It looks like this. And I'm like, I get it. I get that this wouldn't work. But I'm just so doggone tired. Yeah. And then we stopped here. So much for um, sailing in a perfect circle. It was never going to work. But yeah. You know, I mean, we're kind of getting there. It's still a little sloppy. I feel like the projection does matter. It's almost like we need. Oh, right. Anyway. This is kind of working, but it's kind of not. And I'm not certain what to do about it at the moment. I could make the effectiveness like I could make it a byproduct of the sails direction and the boat direction. Like the sail has an optimal direction to be in based on the wind, same as the boat. Because that's kind of what we see here. I mean, look, notice how it's moving, what is that, starboard? I mean, we got to know what we're talking about if we're talking about it at all. Left, let's see, port and starboard or left and right? Yeah, okay. All right, so yeah, left is, when it's on the left side, it's like this is the optimal area for it to be. And it feels like it probably drops off dramatically, I'm sure. Whereas, like here, the whole range is bound to be effective. Here, I'm sure it's a smaller range, but notice that it's at a particular angle, right? Like this is like as effective as you'll get. So I think having the sail, yeah, like relative to the wind, but it would also be relative to the boat. It's like I would need the boat's angle. Huh. Well, we're kind of doing that. It's not perfect. Like we've got our sail and almost makes me think maybe we should let it go push backwards. Huh. Huh. have an idea. Oh, I have an idea. There needs to be sale effectiveness. And the sale effectiveness, like what? Make that a float. And we'll only calculate it when the sale moves. Cool. Should be, I want to say like a dot product. It's clamped at 0. All right. Clamp F. Why are you so mad at me, man? What is it? Oh, there. All right. Clamp F. Something we're going to calculate and max at 1. And this what was I just saying? Boy, I'm getting tired. I'm getting real worn out. All right. Let me think. It's the X. Sale root basis X. And it'll be the dot product of no, this will just be the local X, yeah? Wait, no, I don't just want a vector. If I just looked up the basis, is that transform? I don't want the basis. I want, because it's relative to their parent. Maybe I should just get global. No. No. It'll be vector 3 forward. Yeah? Yeah, negative Z. Okay. So, oh, that's cool. All right. We're going to get a dot product. We're going to clamp the value. I don't want it to go negative. So we want some kind of effectiveness we're going to store when the sale moves. And that'll just be like, how much can it affect the boat locally? No. Yes. No, wait. Maybe this will work. What? Oh. Nuts. Okay. Not effectiveness. You know what? If let's see, efficiency. And I'll call you the same. I really hope I'm spelling that correctly. You'd think at some point it would it all just work out, but no. No, you never have a clue. Okay. This feels bonkers, but we're gonna have the actual win projection value. We're gonna have some effectiveness value, and then we have to have a sale effectiveness. I feel like this thing is really gonna slow down. All right. We're moving at maximum speed. And then we start to turn. And we have to move like this. Notice this is not effective either. Right? So it's, yes, this is good. So between like this angle, trying to get the rudder to straighten out. Between this angle and this angle, we've got this kind of sweet spot. Where we're making progress. And we can even move a little bit in this direction, but notice the sweet spot. That shouldn't work. Yeah, this isn't working either. It's slowly moving along. Why does this work? That starts to move the ship in like a different direction. Which I think kind of makes sense. It would be a little screwy. What doesn't make sense to me is this. Huh. Why do I get the weird feeling I'm like drifting when I do that? I guess I do need to be able to drift a little bit to turn. Oh. Oh, yay. Okay. Where was that effectiveness being calculated? Oh, phi. Yep, totally dead. We made everything worse. I don't know if I'd say this is more realistic. Feels like, yeah, this is worse. So I'm gonna get rid of this for now. Um, it was kind of there, you know. I mean, it was kind of working. Gosh, it just seems like I am projecting the wrong vectors onto the wrong thing. I kind of wonder. Huh. Ah, well, I feel like this is a lot more stable. And I think the rudder effectiveness could be increased. And I think it was like, yeah, this is the fastest way of moving it. Feels weird. Well, now I know why video games typically, well, now I know why they have, um, easy enough sail mechanics, because this is kind of painful. And this moves us fastest. And that hurts my brain. I don't like that at all. But feels like we kind of have a nice. Hmm. Well, it does feel like they all need to do one big thing of linear algebra in the middle. It's like I'm trying to separate it by parts, but maybe they all need to be calculated as one big thing. You know what? What we should have done? I should have looked up the math on this. Because realistically, there's probably equations, yeah. Oh boy. That's nice. Huh. Yep. Everything's dead straight on. Um Open it up like that though, and it's really nice. Huh. Hmm. Yes, I think we'll need to do some calculations. Yeah, look at that. Yeah, wind speed 10 knots. Boat speed is 6. Relative wind is 4. Is 20. Boat speed is 12. I mean, wait, no, that's all. Happy birthday! Oh man. Why doesn't the boat drift sideways? It does a little, but when it does, the keel has to push a lot of water sideways. Okay, yeah. So final wind velocity. Force in the sails. Drag force. Drag from the water. You know, we might have to just apply some forces. This might be the only way to really get it to work. Yeah. Okay, yeah, because we have something applied to the sails. Drag force pulls us the other way. What is that other one? Force on hull and keel. Oh, okay. Oh, I see. I mean, it's kind of there. Sail faster than the wind. Can they? I love how it just goes over this and then it's like, what? I feel like I am not getting enough math on this stuff. Yeah. I love how it's just like, how can all these questions will be answered? No, they're not. You just throw out a little bit on, drag and stuff and like all that, but that's not huh. Yeah, there it is. It looks even scarier, doesn't it? Oh, yes, we're getting into it now. Oh, no. All right. Thanks, Lord Raleigh. Wow, gee whiz, what? Lambda is in feet and V is in knots. Huh. Oh, ho, ho. Huh. It's like close hauling is. This is what we're going to go off of, and I like that it's like the relative wind speed. Yeah, we're going to have to use forces. We're going to have to do a little more calculation. This feels mostly empirical stuff, so eh. Oh, oh yes, good. Oh, we'll be. Oh no, I thought I said this would be easy. Oh, not real math. Oh, what am I thinking? I was like, oh, let's make a simulation. Let's add real math. Yeah. Oh, that's insane. You know, I feel like I'm gonna do one more thing. Oh, hold on a minute. Wait a minute. Where was I calculating effectiveness? Yeah. So we're doing it like this before. And now that I look at it, maybe I'm thinking, you know what? Let's do it based on the z-axis. And instead of the forward, back. And instead of, let's see, 1 to 0, we are going to clamp it, but let me think. This is, again, one of those weird ones where we want it to be maximum power near 0. Oh, shoot. Let me think here. 1 minus. Yeah. That's it. When it's at 0, it's 1. And when it's 1, it'll be 0. So let's try this again. So it's maximum effective. There we go. Should be dead. It should die around here. Do we not add that to the mix? No, we didn't. Okay. Whoa, whoops. Let's add Kurt Angle to the mix. All right. Here we go. Yes. All right. Returning. Not effective. Not effective. This is still effective. So's this. This is less effective. What? I don't even know what's going on here. All right, that. I don't like it because it just feels like it just crumples apart. All right, we'll keep it as this for now. It's gonna be a little weird. There's certain behaviors that don't seem to make any sense. Maybe I should limit the movement of the sails. Yeah. Huh. Well, anyway, it's kind of weird and kind of messed up in so many ways. But I feel like I want to call it for today because let's think here. Wind calculations. We got that. We're generating wind. And we're getting the projection. We're doing kinematics. And we're doing that. So, all right. Let's see. Whoops. All right. Here we go. Do a little changes. Let's see here. Added basic sailing. It does feel really rough. And what I'd like to do is we're gonna have some stretch notes here. Except these are the wrong ones. There we go. All right, stretch. What are we gonna do for this? How it feels to sail a boat. All right. Let's think. What is the stretch goal? Let's see. I'm gonna say use real forces instead of instead of vectors. Well, no, it'll be a vector, but instead of velocities, because I feel like that's really what I'm just doing the whole time. Use real forces instead of velocities. I also want to let me think here. Let's think here. Tilt the boat. And also buoyancy. You know what else we can do? Yeah, we can do that. Just some waves. Just a fluid simulator. Come on. How hard could it be? All right. Let's see. Git push origin. Add wind. Okay. I want to redo that Star Trek bit, but it was fun. That was fun. I can't play that again if I want to. I have to like cut that out of the video. Okie dokie. Let's do a pull request. Able to merge. Good. All right. Approval not required. I should hope so, as I own it. No conflicts. Squash. Delete. Neato. All right. Excellent. Okay. Well, I'm going to call it. Thanks everybody who stopped on by. And for anybody watching this in the future, this whole series is really just a way to kind of document what I do. I love software. I'm always doing something. And I'm like, why not just document that, put it somewhere, and talk a little bit about, kind of what I've learned. I would not call myself a professional. Not just in a career sense. Well, okay, I am a professional software developer, but in a more than that, it's just like I don't know. I like doing this stuff, and I've done this for several years now, and I feel like I've learned a lot. So I'd like to try to pass on, I guess whatever I can, because I've always found it's nice to be helpful. It's nice to find resources, but also I don't know, for people who want to just see like, let's solve a problem and then like walk through it and just all the stumbling and the like, let's do this and this isn't working. Let's try this. It's a process. Yeah. So yeah. Anyway, so I hope you enjoyed watching. Thanks for coming. And, I want to have like a tagline, but I just have no idea what to say. Go try a new angle. That sounds like I'm giving advice to people who are like con man. Try to cheat people a different way. All right, don't cheat anybody. And please love yourself. All right.